All right. Thank you for that. All right. So I don't know if you had the chance to go to that website, but we can come back to it at the end of the session. So let's start our session today. So thank you everyone for joining. Today we are going to discuss the software development lifecycle or system development lifecycle, SDLC, and the various phases. And in doing so, we are going to try to do like an exercise at the end of this session or discussion where we'll actually develop a software, or at least pretend to develop a software. So this session, I believe, will last about 60 to 70 minutes. And again, this is kind of part of the software development security in domain 8. Here we are trying to really discuss the SDLC. And in this session, we are going to do the SDLC, but we will probably do another session next week and then cover the maturity models and some of the software vulnerabilities. And this is the format for today's session. We are going to introduce software development for those who are new to the software development. And for those who are familiar with software development, this should be like a nice refresher. And if you are just starting to study for CISSP, I hope this gives you enough information to get started. And if you have any questions, feel free to interrupt me and ask your questions. Now, if there are too many questions, we may be able to put them at the end of the session and then take care of it. Or you can always ask questions on the Discord um, channel, which is CISSP or Classroom One. And then we're going to talk about the SDLC process. I'm going to define some of the phases in there, I guess all of the phases in there. And we're not going to spend too much time there. We're going to spend maybe 20 to 30 minutes on that. And the focus of today's session will be the interactive session where we are going to build a software. So I'm excited. I hope you're all too. I know it's kind of late in the day. I know I can hear myself. I don't know if it's my microphone. Let me check. But if you're not talking, I would request you to please put your mic on mute. Thank you. And then in the end, we'll do a quiz, which is going to take roughly about 5 minutes. There are about 5 questions. All right. So I know this guy here. He's a very famous in at least in the software development world, I believe. So does anyone use a smartphone here? I'm pretty sure yes is probably going to be the answer. Most of you will say yes. I'm sure most of us
Everyone.
do. Been using it for a while now. The cell phones of today are plagued with software bugs and flaws, and they are there because of the way these cell phones are being sold, especially if they're trying to outsell their competitor. So before we go into the SDLC phases, which is software development lifecycle, and discuss the various phases of software and system development, I want to talk about a very important aspect of SDLC that we need to understand for the CISSP exam. Okay. Of course, Adobe. How many of you people will be able to relate to that? I mean, I'm definitely able to relate to this because I was, constantly updating Adobe applications as an end user as well as a system administrator. Anyways, I thought that was funny there. Time spent using Adobe product and time spent updating and restarting. So for the CISSP exam, I want you all to think about what it means for a CISSP or a security professional to really participate in this SDLC, system or software development lifecycle. And I want you to think about these questions. I don't want anybody to start answering these questions right now. but have these things in mind when you develop a software or when you are in a position where you have to provide your advice or your guidance to somebody who is developing a software. So security, right? That's the big buzzword um, for our CISSP folks. But for software developer, it has not been traditionally security. Okay, so I want everybody to think, where does the security start in software development? When do you start thinking about security? Do you start thinking about security after an application is built, or do you start thinking about application security before it's built or during the phases of application development? How do you make sure your software is secure? Meaning, are you going to perform tests on this application that you just developed? And how do you make sure, or how do you keep your software current? When I say current, continue to be protected against any future vulnerabilities. And just think about all that, especially when we are going to do our exercise today. So what is the most common flaw in a software? I know I don't have any hints on my screen, but anybody can guess? Anyone out there? What is the most common flaw in a software? If you were to generalize, what would you call it? I don't know if my microphone or my speakers are.
Input validation, maybe.
Yeah, that's one of them. I mean, there are many, right? There are many of
Yeah.
them. We all call it a bug.
Hmm.
So, those are the bugs are the things, the big deal, right? In a software, after you developed, you put it out, customer is using it, and he hits a bug. And then he has to report that to the software developer in order to get it fixed. So what you're looking at is actually a bug that was actually found in one of the programs or in a computer system. And this is actually a case that, according to according to Harvard, in 1945, the engineers found this moth. If you see, there's a little bitty moth stuck onto the actual paper, and that was the bug. And they actually had to debug that machine. Maybe I lost that slide. Software bugs can impact the function, safety, and security of a computer operating system or any other application, but most importantly, operating systems. Okay, and that's because Microsoft, Linux, Mac, these are all our main operating systems that we use. And if there is a bug or a vulnerability in those operating systems, those can be exploited to then further exploit other applications running on that computer system. And sometimes, when the software developer is trying to develop a software, he's focused on getting the functionality in and trying to make sure the user requirements are met. At the same time, if there is a security professional, he has no idea what software development is, and trying to communicate that to a software developer can be hard and challenging. And without a proper framework, it is hard to maintain security throughout your software development lifecycle. And I found this ISC Square article. ISC Square puts out reports and other articles every year, and this was released last year. There are about 4 million, and there are professionals missing in these teams that need to be present in order to fix this gap, in order to actually put security first in our application development. We need to find the right people, and we're missing that. So if you've chosen to do CISSP, amazing thing is that there is actually a demand for professionals, and not just by doing CISSP, but any other certification or uh, any other credentials, you can actually it can open up these opportunities for you. But there is a big requirement. So let's talk about SDLC for CISSP a little bit before we get into our exercise. If you go through the OSG official study guide, you will probably see a lot of information about different types of SDLC models. Of course, those are very important. But before you start reading up on the different models, I would really recommend understanding the different phases in SDLC and in what order they occur. Regardless of the SDLC model that they are going to ask you in the exam, if you are not 100% sure of why a certain phase comes first and what happens in that phase, it's not going to be any useful trying to answer that question. So, what are the different phases and in what order they occur, I believe is one of the biggest things you need to really understand about software development lifecycle. Of course, there are different types of SDLC models. Understand the most common ones. You don't have to um, know hundreds of those. There are hundreds of thousands of software companies, and they may have their own SDLC framework that they have come up with. Of course, using industry best practices. So you don't need to know every one of those, but just be aware that there are multiple SDLCs out there that other companies follow. But try to understand some of the most common ones, whether that would be waterfall method, spiral, agile development, and um, there are some combinations of like the spiral I think has waterfall in it and things like that. So be aware of all those different models. Now we are not going to cover those models today. We'll probably keep that for the next session. I know I'm putting a lot to the next session, but hopefully the next session will be just a quick refresh of all the different types of models and the maturity models. Of course, then coming down to different maturity models, understand that when you have SDLC, that alone will not help you get a quality software and a successful company, a profitable company. You need also to have some sort of quality control. And these maturity models help you produce better software quality. So it's almost like saying, okay, I have this standard and procedures I'm following, I'm developing the software, but if I'm not improving my processes, I'm not putting time and effort to actually understand if I need to improve my processes, then I would be left behind. And many companies that did not really catch on um, are obviously no more nowadays. I don't really have an example for you, but what it means to a company is being uh, proactive to the change in an industry and expectations from users and end users, but also making sure their software that they produce becomes better, more efficient, cost effective to develop, cost effective to maintain, and so on. And all of that can come about using the maturity models. And some of the maturity models are like the SWCMM, which is the software capability maturity model. There's also a CMMI. You may have heard that. It's very popular, which is nothing but capability maturity model integration. Again, not going to go too much detail into those in this particular session, but something to keep in mind when you're studying. Okay, so let's go through these different processes and see if we can figure out the differences between the different phases. So any project, whether you're building a house or you are trying to do something new, you need a set of rules and you need a set of requirements before you start putting, uh, you know, before you start digging a hole on the ground. Before you build a house, you need to really scope out the land. You need to really understand what kind of materials you need, what kind of risks exist in that area. Flooding, is there a heavy winds at certain time of the year? You need to really understand all of that. And so all that comes in your planning. Okay. Of course, you start your project, and when you start your
No, no,
project,
it's in the next.
I'm sorry, somebody have a question?
Yeah, I'm sorry, I couldn't mute. Go ahead, sorry.
Oh, that's okay. No problem. So this is a PMP kind of slide, just tells you the different phases in a project. So you start your project, that's project initiation. You plan, but before you plan, you need to gather requirements. And that's what happens in the initiation phase. You also get like the management approval during this initiation project or initiation phase. And then, of course, you do the planning. And when you do planning, you design, you do prototyping, you create models of what you're trying to produce and see if you can come up with ways to make it better. Go out and get feedback from people, and so on and so forth. So that's the planning stage. And of course, then you execute it. In the case of building a house, it's actual construction. You're now putting purchase orders in, and getting procurement to procure materials required for building the house, whether it's windows and whatever you need. You're actually taking action. You're executing it. Also, implementation, which is you're implementing something. It may be in case of a software, you're implementing the software, you're deploying the software, you are putting it in the production, and then in the end, before you close out, you want to ask for user feedback. User acceptance comes into picture. So that's like a general project phases. But for software development, it kind of starts like that, right? So you have the start phase, the project starts. Somebody has a great idea. Oh, I want to build this wonderful app, and that people can use to buy stuff online. It's something groundbreaking. Nobody has ever done it before. That too on a mobile phone, and so on. So that would be like a start of the project. And then you start researching. Is it really possible? Do we have the hardware to actually run this application? Is there really a market demand? And then you get your management to approve it. Obviously, you get the requirements, what you need to do. You have a general idea, but then now you're gathering requirements for specifics. What can this app do? So we are going to do this in our exercise. We're going to build something. So keep in mind all of these phases when we are going through that building process. And then we are going to look at functional analysis. What is functional analysis? So in software development, you define the requirements, right? So there is something called as functional and non-functional. Very different. Functional is what the software can do, right? What is the end product? So the software helps you log into something like a library system, and you're able to search for libraries. What is the non-functional part of the requirement? Non-functional part of the requirement maybe it needs to be available on a cell phone, or it may be a non-functional requirement that says if you have a million users logging in at the same time, you want to have some backup servers that can spin up and provide that platform for it to scale. So that would be kind of like the non-functional type of requirement. But this is the phase when you decide all that, so that you can, you're building the software. You want to make sure it is successfully received and being used in the end user. And so this is where you gather all that. And then your design phase is where you develop detailed design specs. If you ask like a software developer, he'll tell you, there's like a high level design, and then there's like a low level design. And the high level design would be something like a algorithm, or like a flow chart of what happens, before you actually start designing or writing the code. And so in your software development, you write code, and high level design can include different modules. And so, you can divide that software into multiple modules and have a separate development team working on a single module. So let's say you have 5 modules in an application. You can have 5 different teams working on these modules, and somewhere down the lane you're going to integrate, or you're going to start building this together. That's when all of these modules will come together and you're going to start integrating. So design can be where you are doing a high level design, but then you need to get the low level design as well, where you're going to talk about what kind of code you're going to use, or what is actually going on in the code, whether it's opening another window or it's taking user input. Is the user input being validated? Or things like that. It's very specific and very detailed, and sometimes the low level design may actually include some of the programs and queries and so on. So that's the design stage. And the development stage, where you actually start um, putting together the code, right? So you are putting together the code where you're taking all these different modules that's being built, and you're slowly integrating it and testing it, making sure they all talk to each other. If there's an error, there's an issue, you have to go back and say to that particular team, hey team, all the other teams, they understood the requirement, and you guys did something there, it's not working, you need to go change that code because it's throwing up an error, and we need to fix this before the next meeting or whatever. And so this is what happens in the development, and it goes on, and it's like a cycle. It will go back to testing, and they do a testing here. There is a testing that goes on, and they also call it, I believe, like unit testing, where they're testing each unit and they're verifying it, they're validating it, and once it's all coming, like 100% pass, hey, it's passing every time, everything is talking to each other, we need to now move on to the next phase, where we are trying to say that, hey, we are finally have a product, we need to release this product. Of course, you can't just deploy it at the production or at the customer's site. We need to test it. That's when our quality assurance folks come in. This is where the testing happens, where we are testing for all kinds of things. The validation testing, for example, you're checking for errors, you're checking for uh, you know user testing, and there's different kinds of testing for software. All of that happens in this area, and this is to make sure before it goes to the customer site or before it is deployed, you catch as much as possible, as many bugs as possible before it's released. Because once you release it, the cost goes up to fix it. Think about it. So if you have a test environment where you're, or a software development environment where you're developing this application, you can run it and find bugs and fix it. There is really not much cost other than the project cost. Once you release it to your customer, it's already being deployed. You had to go in and do the deployment. There's cost to that. The customer had to schedule these deployments, and they have a cost for that. And now the software is installed in hundreds of thousands of customer sites. And imagine you find a bug, or the user finds a bug, or the customer finds a bug, and the customer says, hey, how did this happen, man? This, it shouldn't have happened. What happened here? You need to fix it. Who is responsible? The company that developed the software. Because user acceptance testing is not finished yet. They haven't signed off on it. So obviously there are checks and balances to avoid this situation, and that's why you have this testing, and that's where the quality assurance comes in. That's where your certification of the software comes in. And also, once it's certified, it gets accredited, or accreditation for the software comes in by the management. Uh, the management of the customer basically says, yes, okay, I accept it, because I see all the that you have certified that this is going to work. You've done all the tests. I can see it. However, there are a few tests that failed. That have failed, and you know what? It's okay. I'm going to accept it. I'm going to accept that risk. So the management can go ahead and sign it and say, okay, I accept it. This is it's fine. Just deploy it. Once it's deployed, then you need also, like, I think they call it the UAT, user acceptance testing. Again, the end users have to accept it. So there's all kinds of tests that goes on just to make sure nothing really bad happens in the production. So your software development lifecycle, SDLC, is there to protect you as a customer, as well as you as a software developer, from such big uh, uh, flaws in your software that can come up if you don't take precautions during the design phase and during the testing phase. If you find some issues, you need to fix it. So that's, and then of course the next phase of the software development lifecycle is the deployment, where you're going to the customer site, or it may be on the cloud, wherever you are deploying it into production. The end users are actually starting to use this software, and you may deploy it in phases. You may have a few users that you say, okay, hundreds. This company has 1,000 users. We're going to release it 100 users at a time and see how it goes. And this way we can apply the lessons learned to the second set of users, and so on. And so there's one more thing that happens at deployment is the user training, how to use this application. That's also covered in the SDLC, software development lifecycle. If you're not able to use the software, there is no usability then, and people may find it difficult to use it, use your application. So this is where training happens, and then the software goes into what is called as a maintenance phase. And in maintenance phase, you can think about Windows operating systems. If you're familiar with them, they have this end of life on so many different operating systems that they had developed about a decade ago. And finally they're saying, we are going to end this particular application or this operating system, because we can't develop this anymore. We cannot maintain this anymore. Technologies have changed. Um, the software languages that we use to develop these programs have changed. The systems that integrated with our operating systems have changed, and so we need to change too. So start from scratch. It's an all new project. It's all new operating system. It's not Windows 9, it's Windows 10. It's completely, let's skip the whole Windows 9 thing, because 7, 8, 9, I don't know if you get that joke. But so in the maintenance life cycle, in the maintenance phase of the software development life cycle, uh, there are more things that happen, right? So there is the patching of the software. Of course, you cannot be 100% sure that you caught all the vulnerabilities in your application. At a later stage, somebody like a security researcher or these bounty hunters, these bounty hunters' job is it's like a gamification of finding vulnerabilities. And so they found a bunch of vulnerabilities in this application that was, obviously being used in this company for many months. And now it's out there. The security researcher has a really cool uh, website where he has shown exactly how to exploit this particular application, with all the information about how he discovered it. And guess what? It's not just the vendors who made this application are looking at it, but also some of the bad and the good, the bad and the black hat hackers are also looking at it. And so you have to now come up with, you as a software developer or a company that develops software, come up with a fix, a patch. And so all that happens in this maintenance phase. So I hope it was kind of clear for everybody, but I would like to kind of pause here for a bit before we go into the next session and see if anybody has any questions about any particular phase in here. I haven't gone too much detail into it, but still, if you have a specific question, please unmute your mic
I,
and ask.
I have one.
Sure, go ahead.
I have one. When you said right for that the certification, so that the technical assessment, who will conduct it? It's a third party, it's a customer, or it's a vendor, or it's a in-house.
So when typically when there is a testing phase, now this hasn't been deployed yet at the customer, and this usually happens. This quality assurance happens in the vendor's area who is developing the software, and that's because when they started the project, they had the scope, and in the scope they had some of the requirements, especially in the functional phase where they had some of the user requirements. And then this is also the phase where security is, taken seriously, and so they want to know whether all of those different requirements that were put forward has been met. So it happens now. It could happen with a third party testing, or it could be something that's internal. Regardless, it happens, before the deployment. So it is not the end customer who's going to be doing all of this testing. Of course, really depending on the situation, right? So if I wanted to put a third party, I wanted to engage a third party company because I do not trust this company that developed that software, I could go and get a third party to test it. Of course, I can do that. So, but it's mostly the software vendor who does quality assurance.
Okay.
So,
Hey, hi.
Hi here. So I also have one question here. So is verification and validation is happening at number of phases here? Like let's say on the design phase, you are verifying that it is meeting our functional requirements and all. Then also in development phase, you are validating and verifying that whether the developed product while doing like let's say secure code review or something like that, or in also in testing phase it is happening. So where exactly we are doing these two processes as well?
yeah, so that's a very good question. So where is the testing happening? So the testing is happening, as soon as they start designing the software. It is constantly being checked. So it's really a cycle. So this particular phase, if I was going to draw, is probably going to be like this till all of their requirements are met, and this is going to continue. And so, like data, like you mentioned, data validation, uh, and I believe they do something called as bounce checking. This is all before they release into the deployment or installation part. So all that happens here. Of course, they are going to also look at, they're going to examine security controls. All that comes into this in this phase. If
Okay.
if somebody has a better answer, please unmute your mic. This is really an open session, and I would really like to see if somebody has another answer to that
So
question.
I thought security is should be built into all the SDLC phases, right?
Yes. Yeah, you start
Okay.
thinking about security, right at the start of the project. Is this application going to handle PII or PHI? All that dictates your planning in what kind of application you want to develop. So yes, in every phase there is this security thing that's kind of integral. Um, even during testing, you're testing for security vulnerabilities as well.
Okay. So if I have to look at this, the starting phase requirement of the application as well as the security requirement down to the planning phase and functional phase. Now, those are just conversations that the developer have with the security team. When it comes on to the design phase, where they actually, is that where they start building start coding or building the
design phase.
software?
So in
Yes.
design phase, they develop what they call as the high level documentation. Sometimes I think they call it HLD. I may be wrong here, but it's it's basically talks about what their application does. It's flowcharts, maybe inputs, and so on. So it's not really coding.
Okay. So that if I get to break it like the security functionality that they will be checking. So that if I had to fit something in there, this is where they start the flow, the high level of the trust boundary and all that, and how the application flows. This is where you want to do threat modeling at this phase, or there's a threat modeling associated with that.
That's a good question. Is it?
I have the answer for that. Yes, you in the design phase is where do you do the threat modeling.
Okay.
Yeah, exactly.
Great. Great. And then
so, and based on that, then what do you need to protect in the application.
Okay.
Yeah.
All right. So I think I'm starting to get this. So in development phase, where you start coding and building and testing, those different modules and integrating them in there, is that where you start doing what they call a static code review? Because you're building that and the code and you're putting it together. And this is where the developers kind of run their code review process.
Yes, so they do what they call it also, like prototyping comes into this phase. I believe
static code review, like SAS. Sorry, I'm trying to put this together.
Sure.
Of what the security feature that they mention in the book. So this is like static code review and dynamic SAS and DAS that they refer to. Yeah.
Yes.
Is this where at this phase is where that's happening between development where you do the SAS and then when they deploy and when you do the testing, that's where the DAS happens?
That is absolutely right. Yeah. So all that happens.
So for development phase, there will be a SAS happening. For testing phase, you will do the dynamic one. And reference to my previous question was, I think we are verifying the test functional requirements in the development and the testing phase because, we verify that your product meets the requirements. So definitely we need to do the verification at both the phases. But I believe that validation addresses how well we are addressing the business needs here. So after developing whole module and something, after that we can do the validation part. So that would be done, I think, in the testing phase only.
Yeah, I mean, depending, right? I mean, it's again, it may go back to development if the testing fails, and so validation is probably happening in the testing phase here, and then it comes back to development if there is some sort of a failed test and they need to look at the code, review the code or whatever. But so
I think that the validation happens after that the UATs, and also it should be into that the testing phase only.
So we have another 15 minutes. We could quickly go through the our exercise.
Product delivery app like Amazon.
Okay, yeah, we could do that. What is it that we need to first do if we were going to build an app? And you said it was for what?
Amazon delivery, I think.
Okay, Amazon delivery. I know it's very popular. That's a good example. Let's do that. So if you're going to do an app for Amazon delivery, what would be our first thing to do?
Scope the requirement for usage. If you mentioned PII, this is a global. Is this app going to be available globally? You know, like Europe, for example, or is it US-based customers only?
Okay. Yes. So we need to
So
scope
it
out.
matters because you're processing data across the globe, so you got to make sure you meet those compliance for data privacy in Europe.
Yeah, I think that before that, even before that, we probably we need to discuss is that if that idea is something that can be built, why it's important to invest resources building that application. Uh, so after being all getting that the management approval of okay, we agree that it's important and it's probably going to help us in, I don't know, having more customers and everything, then okay, let's start.
Okay. So
Point,
management
yes.
approval.
Yep.
All right. So our management says it looks like a great idea. You know, a lot of people come to our stores and they're able to buy stuff, but it would be nice. This would give us a competitive edge over other customers. So yeah, let's go and build it. So you know, we are still at the start phase, and obviously we need to scope this out. So yes, we definitely need to scope this out, and we need to really understand what is our reach and where our customers are. So obviously that would all go into this planning phase. We would need to look at compliance. We would also need to look at if we have the resources. You know, we need to be able to build this. So we need to find out, you know, if we can even, we have software development team that we have in-house, or we need to reach out to another company to develop this application for us. So all of that will be definitely in the scope, and then it'll be the planning phase of this SDLC. So quickly, let's say we have all of that and we have the management approval to move ahead. So we go into what we call as getting the functional requirements, right? So that would be the next phase. So what do you guys think we should do next? Anybody?
The supportability of, I guess if you're building an applet, it has to be deployed and it has to go on a smartphone. So you got to make a decision. I'm not sure if this is a functional. I think it's a non-functional requirement that it has to be, you know, it has presence in iOS and Android, because those are the two major, yes, phone that out there in the market, for example.
Right. So yes, so we need to define the functional and non-functional requirements. And so the reason why we need to define these is because we need to know what we are building, and without knowing what the user or customer or us, whoever is building this, what do they have in mind in order to build it, you need to know what to build. And so these functional requirements and non-functional requirements give us that. So we need to look into what kind of functional requirements, you know, how many pages, if it was like a website, how many pages, but then this is an app. So how many, I don't know what they call different pages in an app, but let's just call it pages. How many pages?
An applet.
An applet. Okay. Yeah.
Like if you download this applet, you want ease of use and functionality for the user, right? So you know you want to be able to, you know, onboard the users to be onboarded easily, and you got to consider the login factor, the onboarding, the, you know, and if the session timeout is too frequent, the usability of that will be not very friendly, and the user might be complaining about it, you know.
Right. So yeah, login, Do we want to provide the users with a profile page, so they can
Yep.
change their own information, cart, obviously to add their items, and integration with payment systems, things
Yep.
like that. So all that becomes our functional requirement. And of course, we have all of this. It all looks nice on paper. And what's the next phase? What do we do with all this information? How do we get started on getting these, even converted into like what do you think is the next stage?
Design.
Design. You want to have a high-level integration design. I mean, it's a software or the app that has any integration with other components that allow it to function as a whole. So since you're writing an applet and you mentioned, payment card, I mean, who's your payment card vendor and how you integrate it, and what applet underneath are you going to use to do this transaction to make sure, it's PCI compliant if you're going to have to do it on from the point of the cell phone or the Android from the applet
Right.
to the payment vendor. All that has to be considered, and is it a reputable vendor that you're going with, and has it been vetting and the PCI compliant,
Sure.
and all that stuff.
So at this point, you have this high level, but what will actually end up happening in most cases is this high level will be broken down into many low level requirements.
Mhm.
And there is a possibility that you may have a team, let's just say team A, B, C, and D, where there will be, let's say there's a project lead for the team, and he manages this particular module. So these high level gets, kind of broken down into different modules, and then they can go in different directions in different places. And of course, they may have their own testing and design and testing before they can actually come back, and which would be our next phase, which is development, which, by the way, this is all development, right? So they are developing this product. However, the actual development takes place when all of these modules are starting to integrate into this one app. And so, that's when everything's coming alive. So obviously our next phase is development. And so,
Sorry.
yeah, go ahead.
Like someone mentioned previously, also during the design phase is where like the flow of the application is built, and also the threat modeling is made.
Yes.
Right.
So to understand, okay, if this is going to ask, I don't know, if this part of the app is going to ask like this database or this type of service, then we need to protect that and
Yeah,
consider it.
yep. Transport layers, API calls, the tokens, how often they refresh tokens,
Yeah.
time out for the tokens, etc. Those are security considerations, because obviously you don't want the API tokens to be instantly doesn't expire, as it would be, an attack vector that an attacker could, eventually compromise the token. So you want to refresh a token
Right.
often and change the API token, and you want to make sure your traffic is secure in the latest and greatest, encryption methodology they use now. It's TLS 1.3, I think. Stuff like that, right?
Right. Yep, that's a good point. Definitely. So that all happens in the design phase.
Yep.
Before it is obviously developed, and all the other considerations that was created in the functional and non-functional requirement has to be met in the design phase before we can proceed to actually developing this product. Because when you're developing it, you don't want to go back and say, oh, we missed the requirement. Obviously that does happen sometimes, depending on what kind of requirement that was. But most of the SDLCs that we use today nowadays, helps us make sure we don't end up with missing a requirement or not implementing it fully. So this is, like I had mentioned in the previous slide, it's almost a little bitty cycle right there between the design and the functional requirement, where they go back and forth and make sure they get that right before proceeding to the development phase. So in the development phase, we're getting an app being developed, and it's it could be that it will be released. With all these new companies, doing their beta versions nowadays, they just throw it out. That's it's a free software most of the time. If you find a beta, and they're actually using the user to kind of test it out. Most open source softwares are like that. But in a company where you're trying to protect somebody's data, where we are making sure the credit card information, also the personal identifiable information is kept safe. We obviously will go through a rigorous testing to make sure that this particular app that we are developing is passes all of our quality tests. And so that will be the next phase before it is deployed and being downloaded millions of times before it's being used. And so I know I kind of ran really fast at the end there, but I hope everybody had a good understanding, and you probably already did before you came to this. But my main goal for today's session was to kind of give you an idea of the SDLC process. If you're not familiar with it, I hope you are now. And uh, I think we have another 5 minutes left. So what I'm going to do is, if you have more questions, please put it on either the classroom channel. I would prefer you put it there. That way we can continue discussing. Again, don't hesitate. Just throw it out there, and let's discuss and get that cleared. So let's go and jump into the quiz. Let's see the app.